Alright, so let's take a look at these harder type binomial questions, okay? So first of all, we have 1 plus px raised to the n power, right? If we were to expand this out, it basically says that this would be our first term, second term, and third term, okay? So basically what's happening is we take 1 plus px to some power. If we were to expand this out, if we knew what p and n were, it would give us 1 plus 50x plus 1125x squared, right? These would be the first three terms. So this is the important term that we're going to use right here, right? So the term that has x squared, we're going to calculate this using the binomial coefficient, right? So this will be n. We have 1 here. We have px. Now, if we're trying to get x squared, this exponent has to be a 2. It cannot be anything else. So this would be n minus 2. And then I could put the 2 right here, right? So now I need to calculate this n choose 2. So that would be n times n minus 1, n minus 2, dot, 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 divided by 2 factorial, which is 2 times 1, times n minus 2 factorial. So n minus 2, dot, 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 n minus 2 simplify out. So we end up with basically n squared minus n over 2, right? 1 to any power is going to give us 1, and then this will give us p squared x squared. And we know this is going to equal this term right here, which is 1125x squared. Okay? Now, let's simplify this out. So basically the problem is, first of all, the x's are going to divide each other out. We have this p squared here, right? So if I were to, let's just move this p squared to the front. So I have p squared here multiplying with n squared minus n over 2 equals 1125, right? So the issue is we have two different variables, right? So we need to do some sort of substitution. So whenever this happens, you have to understand that, okay, you're going to probably have to try and find some other equation and solve for p so that you can substitute it in, okay? So using our problem, well, we also have this term right here, right? We have this one right here, the 50x. So how do we get something with just an x, right? So basically we have, let's calculate that. So we have n, we have 1, we have p times x, right? And we're just trying to get something with just x to the first power. So we know this has to be a 1. So if this is a 1, this would be n minus 1, and this would be 1. So n choose 1 is just going to give us n. 1 to any power is 1. And then this is just going to be p to the first and x to the first power, right? And this is going to equal this 50x. So we get n times p times x is going to equal 50x. The x's divide each other out, right? So we know p is equal to 50 over n. Okay? So now that we know that p is 50 over n, we can use this and substitute it in here. That way we can get the whole problem in terms of n. Okay? So this is going to give us 50 over n squared times n squared minus n is equal to, now I'm going to multiply by 2 on both sides, so I'll make this 2,250. Okay? So I square this, I'll get 2,500 over n squared times n squared minus n is equal to 2,250. Multiply both sides by n squared. Then I'll distribute the 2,500. So I get 2,500 n squared minus 2,500 n is equal to 2,250 n squared. So let's set it equal to 0. So I'll minus this at this side. I'll get 250 n squared minus 2,500 n is equal to 0. Take out the GCF, which is 250 n. Leaves me with n minus 10 is equal to 0. So n is going to equal 0, n is going to equal 10. Okay? Now, n equals 0 doesn't make sense, right? If we go back to the equation, right, to our problem here, if n is 0, anything to the 0 power is just going to equal 1. So that wouldn't give us our first three terms here. So we're going to reject that one right there. So we reject n is equal to 0. So we're going to reject this, right? So we know n equals 10 is our solution, okay? All right, so let's take a look at this next question here. So usually the harder type binomial theorem questions, sometimes you'll have a binomial being raised to some power multiplying with another binomial, okay? So when you have this situation, what I would recommend is, I would typically recommend multiplying and expanding out this binomial being raised to this power. All right, so simplify this out. And I would do it using Pascal's triangle typically. So if the exponent is a 5, the numbers from Pascal's triangle that we're going to be using is 1, 5, 10, 10, 5, and 1. Right, so 10, 5, and 1. And then we've got 2, 2, 2. Now let's think about this. Since we're trying to find the coefficient of x squared, anything bigger than x squared is not going to be relevant in this problem. So I'm not going to expand out this whole thing because that would be a waste of our time. So you want to be a little bit strategic and think about how much you need to do whenever you're doing these expansions. So for example, this would be 0, 1, 2. So this would give me x squared, and that's pretty much all we need, right? Because if I expand out these other terms, they'll just give me x to the third, x to the fourth, x to the fifth, which aren't relevant to what we're trying to do in this problem. And this would be 5, 4, and 3. And then we're going to simplify all this out, right? So this is going to end up giving us 32. This right here is going to give us 5 times 16 times negative 3. That'll give us negative 240x. And we multiply 10 times 8 times negative 3 squared would give us positive 9. So we get a positive 720x squared. So if we expand this out, these would be our first 3 terms, right? So we have 32 minus 240x plus 720x squared dot dot dot. So we would have some other terms here that we did not expand out, right? So that's why I put the dot dot dot. But these 3 are really the only ones we need. Now we're multiplying this with this 1 plus 2x over here, right? This 1 plus 2x. Now we're trying to find the coefficient of x squared. Let's think, what are all the ways to get x squared? Well, if you multiply 720x squared times 1, that would give you something with x squared, right? Some coefficient x squared. Or you can multiply the negative 240x with this positive 2x. So if you take 720x squared, multiply it with the 1, or if you take the negative 240x and multiply it with the 2x, right? So we end up with 720x squared plus negative 480x squared. So if you simplify that, looks like that's going to give us 240x squared. So the coefficient is 240. Okay. All right, let's take a look at this example here. This one's very similar to the last one we did, right? The only difference is this time we have this binomial raised to the 5th power, and the other binomial is also raised to the 6th power, okay? So basically what we need to do is we need to expand both of these out using Pascal's triangle, then we'll be able to see which combinations we need to multiply to give us what we want, which is x squared, okay? Now, once again, we want to think, when we're expanding this out, since we're trying to find the coefficient of x squared, you don't need to expand out the whole thing. You just need to expand out enough of these, all right, expansions to find the combinations that you need. So from Pascal's triangle for this binomial, I'm going to be using 1, 5, 10, 10, 5, and 1. So we've got 2 here. We've got negative x. And that's probably all I need, because when I put 0, 1, 2 here, remember we're trying to get x squared, so this gives us x squared. All these other terms are not going to be relevant in this problem. And this would be 5, 4, 3. So we're going to end up right here. That says 2 to the 5th is 32. Over here, 2 to the 4th. That'll give me 16 times 5. That'll give us negative 80x. Then over here, we have, that would be positive, and then we end up with 2 to the 3rd is 8. So a positive 80 x squared. Okay, so we have 32 minus 80x plus 80x squared, dot, dot, dot. So there's some other terms, but we don't need them. Now, from this binomial over here, I'm going to use Pascal's triangle. So the first few numbers are going to be 1, 6, 15, 20, 15, 6, and 1. And once again, remember, we only need, right, to expand just the terms that are going to be relevant to us. So when I have 0, 1, 2 here, so this will give me the x squared, so I really don't need to do the rest of this, right? So don't waste time doing that. And we know 1 to any power, that doesn't even make a difference. That's always going to equal 1, right? So 6, 5, 4. So if you work this out, this is going to give us 1. This is going to give you 12x. And then this one over here is going to give you 4, so that'll be 60x squared, right? So when you expand this out, we're going to end up with 1 plus 12x plus 60x squared, dot, dot, dot. Right, there's some other terms we don't need. So now that we have it all expanded out, we can check to see, okay, which combinations can we multiply to give us, right, something with x squared. So obviously, if we multiply right here, this 80x squared times this 1, or this negative 80x times this 12x, or the 32 times this 60x squared, right? So we have 80x squared, right, times 1, right? Or we have the negative 80x times the 12x, or we have the 32 times the 60x squared, right? So this will give us 80x squared. This will give you a negative value, 80 times 12. That will give us negative 960 here, x squared. And 32 times 60, that gives us 1920, positive 1920 x squared. And so if we simplify all this right here, I believe we end up with 1040 x squared. So the coefficient is going to be 1040. Okay? All right, so let's take a look at another example right here. So basically we have this binomial being raised to the n power times 3 plus nx squared. So if you simplify all this and multiply everything together, 9 would be the first term, 84x would be the second term, and so on, right? So first thing I would do is, since this is being squared, I would just square this so that I would get 6nx plus n squared x squared, right? So if I square this, I would just get this value right here. Now I'm multiplying this with this binomial over here. So basically, let's think about what's happening. If I were to expand out this binomial, right, if I knew what n was, and if I were to expand this out, basically what would happen is I would get, well, 1 to some power, which would give me 1, all right, plus, and then I would have some coefficient with an x, right, plus, or it could be minus, right? Well, actually, this is a plus, so yeah, it would be a plus. And then we'll have some coefficient with an x squared, dot, 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 and then it would just continue, right? So basically the idea is if I were to multiply all this out, I know that the first term would be 9 and the second term would be 84x, okay? So let's use this 84x term right here. How would we get 84x, right? So that means how do we get something with an x? So let's think about it. To get something with an x, we would have to multiply 1 times this 6nx, right? Or you multiply the term over here that has an x with the 9, correct? So basically the idea is we have 1 times 6nx, or, so plus, we have 9 times the term that's from over here that's going to have just an x, all right? So we need to calculate what this term is, right, using the binomial coefficient, all right? So let me calculate that. So I'm going to set this up to 3 parentheses. So we have this 9 just hanging out here, right? So let's ignore it for now. So we're going to set this up. We know this is going to be n right here. And then let's go back to our question real quick. So this was 1 and 2/3. This is 1. This is a 2/3 x. Now we know this exponent must be a 1 because we need to have just x to the first power. So this would be n minus 1, so I could just put a 1 here. So n choose 1 is just going to give us n. I have this 9 here. 1 to any power is 1. And I have this 2/3 x, right? So if I multiply all this out, what's going to happen is I end up with 3's and the 9 reduced, so I'll get 6 nx plus over here 1 times 6 nx is 6 nx, and remember these two are supposed to add up to equal the 84x, right, from the second term in our question. Remember it was 84x right here. So well, 6 plus 6 will give me 12 nx is equal to 84x. The x's divide out. Divide by 12, so n is going to equal 7. Okay?